some deep Bitcoin knowledge.
That's great. Okay, Jesus, it's over to you. Do you need to
Awesome.
share?
Yeah, I'll be sharing in a second.
Okay, cool.
Okay.
That's great.
Yeah, before I do, I definitely want to just say to whoever's in the crowd, this is going to be a fairly very technical discussion. So please feel free to pelter me with questions in the message, so that this is a conversation, or else I feel like I'm just gonna drone on, and I don't want to lose people along the way. And or I hope at least one of you guys walks away with like a deeper understanding of Bitcoin. So that being said, I'm going to be talking about Bitcoin script. I typically would ask for a show of hands if you've heard of Bitcoin script or if you are familiar with that term at all. But in case you're not, Bitcoin script is basically the programming language that exists on Bitcoin. Not a lot of people know that you actually can program on Bitcoin. You don't need, you know, expressive global smart contracts like you have on other chains to be able to do a lot of neat stuff. But script is archaic, confusing, ugly to read, and so it's been a really big barrier for getting developers into Bitcoin, and why a bunch of developers left in the first place to go to Ethereum or to build on other chains. So I'm going to be giving a quick introduction at the highest level that I can on Bitcoin script. And again, please feel free to ask me questions along the way, uh, so people can follow along. Okay, cool. Everyone can see my screen. Cool. Let me see. How do I start? Okay, cool. Yeah, and to give you guys further background, in addition to what I've to like the introduction of what I do at SetDev and Bitcoin Yield, I also wrote a lot of Bitcoin development tools and an IDE, which is a platform for programming for Bitcoin script as well, called BitScript. So bitscript.app. And this talk that I'm about to give is actually a talk I've given many times, showcasing basically how to program on top of Bitcoin. Okay, cool. So we're not going to go over two or three examples. We're going to go over one simple example. So we're going to start with the basics of why even learn script in the first place. What is the syntax, or how is it written? What are the rules of that language? And then going through an example. Okay, cool. So I learned script. Well, because in my humble opinion, if you don't understand how script, public keys, or digital signatures work, you don't really understand how wallet addresses work and what's happening underneath the hood. Which again, if your intention is just buy, sell, and like speculate on Bitcoin, completely, it's not that big of a deal. But to me, as someone who joined the space many years ago, I'm still a really big believer in self-custody. And so if you want to self-custody correctly, you have to continue looking under the hood and understanding how a lot of these properties in Bitcoin work. Okay. So hopefully everyone here knows that to generate a wallet address, you start with a private key. Most days, most of the time, people now start with a seed phrase, which are those 12 to 24 words that you see people, write down on paper, or, put somewhere securely, or put in password apps, etc. So you go from seed phrases to private keys. From private key, you can generate a public key. And so when you send Bitcoin to someone, what you are really doing is you are unlocking a UTXO, which is an unconfirmed transaction, an unspent transaction output, and you are giving it to someone else by putting before their public key now their wallet address and saying, "Hey, this person can unlock this UTXO." So we go from private keys to public keys, but then we go from public keys to wallet addresses. And so that's what most people here are probably familiar with. If you use Coinbase, Robinhood, or like any of these popular wallet services, you're probably using a pay to taproot PT P2TR at the bottom wallet address. But the point that I want to highlight here is there is actually various wallet addresses in Bitcoin, or types of wallet addresses. If you go to a block explorer such as mempool or like any of those, you will see these little words of like P2PK, P2PKH, P2SH. And so to really understand what those mean, you have to take a step back and look at the steps that happen between from a public key to a wallet address. So how does that transformation happen? And a little bit of history here. Actually, I think I see messages. Does Claude help with script? So to answer Cheryl's question, yes and no. The difficulty with script is, and I'll say this about the difficulty with using Claude or ChatGPT with any like applied cryptography programming, such as this, or smart contract engineering. One, there's not as much data for the LLMs to train on. Two, it's much more punishing when you make a mistake, right? If you make a mistake on a website, you can just push code again and it's not that big of a deal. But if you make a mistake in a smart contract or in a Bitcoin wallet address, you're going to lose funds. Um, so I do use LLMs, but very sparingly when I'm doing really low level stuff like this. Um, and I will answer the quantum question later because I think a lot of the fears there are overblown, and I'm happy to get into like the depth, into the deep parts of that as well, if that's of interest to the group. But that being said, again, I want to walk you guys through script. And the very first wallet address, wallet types, P2PK, when Bitcoin launched in 2009 with Satoshi, Hal Finney, Nick Szabo, and all those early Bitcoiners, they used a wallet address type called pay to public key. And all that meant is very simply the wallet address was just your public key. Now that hasn't been the case since like 2014, 2015, because now wallet addresses are generated with some variation of a public key and a script. And that script can be many different things. So for example, multi-sigs. If we want to create a wallet address where two of the three of us are required to sign, or three out of five of us, that is a type of script. A hash lock. So say you want to put Bitcoin in a wallet address that is unlockable only with a password or like with like some text. That is a hash lock, and that is also a certain type of script. And so, long story short, if you want to be able to use Bitcoin in really expressive ways, you have to learn how to use script. So I'm going to cover the basics today. And again, feel free to continue asking questions. That was, yeah, first two good questions. Okay. So before I dive into the exact part, I just want to quickly review how transactions in Bitcoin work. All transactions have inputs and outputs, right? And when you spend from an output, you are basically putting an input together with something called a SIG script. And you concatenate it with the output that you're trying to unlock, which has something called a pub key script. Basically, these are how transactions are unlocked and then relocked. And both of those fields, SIG script and pub key script, they both they both are just this scripting language that I'm talking about. Okay, so okay, last review before we dive in. Signatures. Digital signatures are just the single most important primitive when you want to understand what's happening in blockchain, not just in Bitcoin, but in Ethereum or Solana. Any blockchain uses digital signatures at its core. And all a digital signature is, it's a message that is signed by a private key that is then broadcasted to the network where a public key can verify the message. And in each blockchain, the message is just the transaction. So in Bitcoin, a digital signature is used with a public key and the transaction that you are completing, and that is stuffed into a transaction field. Okay, cool. Again, if I am going too fast or if you have any questions, please feel free to ask me because I know this stuff is extremely complicated. Again, we're talking about things where 1% of the 1% of Bitcoiners dive into. So I understand this is very, very high level items. Feel free to ask any questions or stop me along the way. Okay. If you're familiar with programming, such as JavaScript, Python, or anything else, you're used to seeing really nice English written words when programming, such as if, or and, or anything of those types, right? Just really basic programming principles. Script does not work this way. And again, this is why Vitalik went out and basically said, it's impossible to program on Bitcoin. We're going to create Ethereum. We're going to create a much nicer programming language for Ethereum. It's because script is written in a really, really ugly way. And to give you guys some context here, if any of you guys remember hearing about the assembly programming language, which was like 20, 30 years ago when programming was first coming out on computers, um, script follows the assembly programming language way of functioning, which again, super, super, super old school. I doubt anyone here has even looked at assembly code just because again, these days people write JavaScript, Python, really, really simple abstract languages. But the core of script is it functions instead of having if and like English written words, it functions as an array of bytes. And so within Bitcoin, how you guys saw here, and this is actually a snapshot from a mempool explorer. Okay, yeah, exactly. So this is actually like a mempool explorer. So you can see here there are two scripts, and that's exactly what we see here. And so the basic body of script is you pass it. Everything is either the size of the data you're about to push, and so the size of instructions, or data itself. So in this first example, we are seeing 0x20. Then we are seeing 0x0, blah, 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 blah. Okay. This first part, 0x20, and as you guys see here, everything is written hexadecimal. So, and I'm not going to cover that here, but 0x20, this translates to 32 bytes. So this is an instruction saying, hey, Bitcoin programming language, we're about to push 32 bytes of data. We're about to send you 32 bytes of data. Why would we send 32 bytes of data? That's actually the size of a public key. So in this example, we are saying, hey, Bitcoin, we're going to pass 32 bytes of data. Then we're seeing the data to push. Here are the 32 bytes. Cool. So everything is either data or an opcode. And again, opcodes you can think as functions, commands, operations, the ifs, the ands, the or, the greater than, less than, addition, subtraction, um, maybe some hashing functions, right? So SHA-2, SHA-2, SHA-1, etc. Or it's data. If anyone here has played around with inscriptions or ordinals or NFTs or anything like that, again, this is how you're able to have all this data on the Bitcoin blockchain. It's because script is actually built to hold data. Cool. So right now I'm going to go over the basics of a stack. And for those of you that said you're familiar with assembly, this should be somewhat familiar. I'm going to try to make the screen smaller. Here we go. Okay, cool. And so the way Bitcoin script is interpreted is it functions in something called a stack, which is just really a simple structure that follows a last in, first out life cycle. And so in Bitcoin Core, the stack, so this compiler and the opcodes, the functions, etc., are primarily handled in a file called the script/interpreter.cpp file. And again, this is actually like a core Bitcoin file. If you go to the Bitcoin Core GitHub and you look at this file, you would see all the logic for the programming language. Cool. So let me continue here on an example. Okay, cool. Yeah, data and opcodes are pushed to the stack and consumed one at a time. Sometimes data is pushed back or pushed out of the stack. A node considers a transaction valid if there is a single remaining 0x01 or a value of true on the stack. So that was a lot to go over, but I want to clear that up. How transactions work is you have a UTXO with an with some kind of lock. When you go to spend that UTXO, you have an input and you say, "Hey, I have some code that can unlock this lock." A node takes both of those scripts together, puts them together, goes through them one opcode at a time or one data at a time. And if at the end there's a single value of true, then the node considers your Bitcoin transaction valid. Okay. So that's actually like the entire life cycle at a high level. The next few pages, we're actually just going to go through an example, and then we can go into questions here. But real simple, all we're going to do is review a programming language that adds two numbers. That's it. And so what you guys are looking at is actual Bitcoin code that adds two numbers. And so if obviously you wouldn't want to do this, but if for some reason you want to create a Bitcoin address where you write, what does 1 + 1 equal? And whoever answers two can spend that Bitcoin. This is how you would do something like that. Cool. So again, we're literally going to go byte by byte and show how this compiles to a script that adds two numbers. Okay. So going from left to right here, you see first is highlighted 0x01. Okay, cool. When parsing a script, again, you always start by pushing some data to the stack. We can therefore infer that the first byte is always a data size operation. So that tells us what we're about to push. So here we see 0x01. What does that mean? Well, we know we're about to push 1 byte to the stack. Cool. So now we're on the next byte, 0, 1. So now that we know that we're looking to push only 1 byte worth of data, we only have to look 1 byte forward and grab it. So here we're saying, okay, cool. Let's grab the number 0, 1, and we're going to push it to the stack. Let me move this thing. I don't like that. Sorry, 1 second. Okay, cool. All right. So now we have this next data that says 0, 2. And so remember the first 0, 1 that we saw, we pushed 1 byte of data, then we pushed 1 byte. So we know again that this is going to be another size command. And it's saying, hey, this time we need to push 2 bytes of data. So we're going to go ahead and instead of grabbing 1, grab the next 2 bytes. So now we're grabbing 03E8. Because again, 03 is 1 byte, E8 is another byte. And if you look on the left, you would see that 03E8 in hexadecimal translates to 1,000. And so here, all we're saying is, okay, cool. Now we're going to push the number 1,000 to the stack. And if you guys look at the bottom here, you would see 1,001. Awesome. And so now the last command, we see 93. That is actually an opcode command in Bitcoin script. So some of these bytes have a function or a command that's mapped to them. 0x93 means add in Bitcoin. So here, real simple, all we're doing is say, okay, so now we need to add 0. And so now we need to process what is inside the stack and add it because this opcode takes in two items. And so here we added 1,000, we added 1, and we see that we have the result of 03E9 or 1,001 within the stack. And with that, I'm going to go ahead and wrap that example up. But there we go. This is a Bitcoin script for adding two different numbers and getting a result back, which again, why you would use that, what you would use that for totally depends. But I wanted to highlight how, again, script is the glue that takes public keys to a wallet addresses. And that script is itself really, really expressive, and you can write programming languages with it. I'm gonna wrap up in like 1 or 2 minutes by just showing you guys categories of opcodes that exist. So anything crypto related, again, hashing, verifying signatures, flow, if and else, then, uh, math, adding, subtracting, etc., pushing data to the stack, which you guys saw, and then functions that are native to a stack program, such as maybe switching the items, maybe dropping one of the items in the stack, etc. Okay, and here we go with like some more examples. As you guys can see, these are opcodes that exist in Bitcoin, what they do and what their values are. So check signature, hash 160, hash 256, op if, op and, op or, as well as the bytes that they're represented by. Okay, and so with that, I'm going to go ahead and stop sharing. Again, I know that was fairly low level, but not a lot of people talk about Bitcoin script. So I hope that it was at least interesting and got you more curious about how expressive Bitcoin can be and how you can use Bitcoin in ways that you're probably not seeing in regular Coinbase, Robinhood, etc. wallets. Okay.
Wow, that's fantastic. That's a long time since I've gone into that, a deep dive of that nature. I think the last time was when I did my master's in digital currencies, and I think that was the last time I had a look at it. But it is very interesting because people are dealing with this every day, and it's pretty crazy how this is like what are we now, 15 years old, or how many years is it? And that it's still relevant. And yes, it's so basically constructed, so absolutely fascinating.
Thank you. And yeah, it's worth asking why Satoshi decided to implement that particular flavor of programming language because it is,
Yeah.
again, it is a callback to programming languages from like 20, 30 years before Bitcoin was invented. So it's curious as to why he chose that language versus any other programming language.
Pretty crazy, eh? So please put up your hand if you have a question. Anything goes. So, don't
Yeah.
think that, don't feel stupid or whatever to ask a stupid question because there are no stupid questions.
Or feel
And
free
it's
to
very,
ask any question about quantum or anything that's like highly technical about Bitcoin. Feel free to ask me that. Probably fairly well versed in the topic.
are you doing development effectively on? I mean, what is it that you're actually doing at the moment, from a Bitcoin deep dive perspective?
So yeah, so right now I have so outside of like I mainly do operations for my companies and don't write
Yeah,
software that much these days. But
yeah,
I am staffed on one Bitcoin L2 engagement where I'm working on basically the consensus between how this L2 works with Bitcoin, how they communicate, how they send data back and forth to each other.
got it.
And to answer Cheryl, why do I hypothesize Satoshi used it? Uh, there's a couple theories here. One is that Satoshi himself wasn't. He was an extremely good systems engineer, but wasn't a phenomenal programmer. And so the theories are that assembly was probably one of the few languages that he was very familiar with. There's that. There's the fact that assembly itself very is very optimized or very cheap. It's basically one level above machine language before bits, right? And so when you're in an environment that you're computationally constrained, like in Bitcoin, where you have nodes that are ran on Raspberry Pis or whatever, you probably don't want to waste uh, a lot of storage, a lot of usage on the abstraction from going from assembly to JavaScript or to compile it to higher levels. So optimization is probably another reason why I pick that. And the third is because he probably correctly predicted that Bitcoin should be very complicated to program with. So there's also that argument in terms of like he didn't really care that it was very developer friendly, uh, which you know might or might not be the correct viewpoint.
And Jesus, like to what extent is Bitcoin changing? How difficult is it to get consensus to be able to make any changes to the protocol? And to
It's
what
very
extent is
difficult.
it changing or could
Yeah,
it
it's
change?
it's it's very difficult for good reasons. I've now been around for like 3 cycles now, and I've seen a lot of flare-ups within the development community, people trying to make changes. And it's very, very uphill. You need consensus from a lot of different groups and a lot of different parties in the Bitcoin sector, and they don't get along really well, and they don't really play well. Um, so it's really rare that you get a strong enough consensus to update Bitcoin, which again, I think it's a good thing. I think it's good that it's hard to update. I would say in the last 2 or 3 years, we've already seen people trying to update Bitcoin to have different opcodes such as opctv or opcat. That was like 2 or 3 years ago. Then this last year, we had this battle between knots, like so people who were running the knots implementation on their node or pushing for BIP 110, which is basically trying to remove any of the so-called spam or NFTs or inscriptions from Bitcoin. And now we also have the quantum, honestly, kind of distraction more than anything. But since Bitcoin takes such a long time to update, it's fair game that we're dealing with the quantum fears now. But yeah, all three of those people have been trying to change Bitcoin and none of them have come to fruition yet. The quantum working group probably has the most momentum at the moment, but that's basically because that's a universal fear. That's a everyone in this sector, even though it is very, very small fear as of now, and maybe in the short term, it's something that every party would suffer from. And so it actually has like a lot of people are aligned on making sure that's taken care of. Alejandro, Jesus, what are the most compelling use cases for Bitcoin in your view, and how could that limit potential? What do you think about the Lightning? What do I think are the most compelling use cases for Bitcoin? Again, I've worked on other blockchains and other ecosystems. To me, Bitcoin is the only digital currency that is strictly focused on becoming hard money separated from the state. And it is fulfilling its mission. And so that to me is and always will be the most compelling use case. The fact that you, me, or anyone on here can flip a coin 256 times and we've essentially generated a private bank account is an insanely beautiful property that to me is like the what I care about the most about Bitcoin. To answer your further questions, um, I'm a yeah. So for SetDev, I actually do not just work on Bitcoin, but a lot of the Bitcoin L2s. So stacks, rootstock, Lightning Network, Liquid. I've worked with. I've done. Well, my firm has done contract work with most of those, if not all of them, at this point. Um, I think those L2s are the response to Ethereum. And I think just like how in our TradFi world we have Fedwire as like the underlying layer on which everything is built on top of. I think in this new digital currency world that we're building, Bitcoin is basically the Fedwire where infrastructure is going to be built on top of it. And so you're seeing L2s built on top of it. You're going to continue seeing L2s built on top of it. I'm bullish on the L2s, but I do think most of them are going to die. I think it's going to be a very, very difficult game to win, but there will be some L2s that roll up to Bitcoin and have significant adoption. Yeah, I hope that answered your question, Alejandro. But yeah, I appreciate the questions. Anyone else? Again, feel free to ask me anything, um, particularly technical about Bitcoin.
I was curious whether who are the like Vitaliks of Bitcoin? I mean, are there a few of these gurus that are like holding the space and
That's what I
really
like. There aren't.
listening to it?
There aren't. There are a few influencers and a few influential developers, but there is no single Vitalik character in Bitcoin.
Hmm.
There is no single one, which I think
Wow.
is, which again, I think is one of the big pluses for Bitcoin.
Yeah, yeah.
Yeah.
It's properly decentralized.
Yeah, exactly. Properly decentralized.
And then what about what other cool things are being built on it now? And what do you think is going to succeed and what do you think is just a waste of time? And what is it designed for? And what do you think could be done with its design currently that would be
With
super cool, beneficial, and decentralized and so on?
with Bitcoin or with
Yeah,
L2s on
on
top
top
of
of
Bitcoin.
Bitcoin, yeah. Because I mean, there's so much talk now of being able to do like smart contracts on Bitcoin and people developing on it. It's the new cool thing. I mean, obviously that's gazumped by AI these days, but what are
Yeah,
the things
my
now
opinion
really you
is
think are going to be successful?
yeah, my opinion is any use case that you see succeeding in other L2s or other L1s or other L3s, the successful ones are going to be transported over to, if not on Bitcoin directly, in the L2s, um, in the L2s directly. And I think lending is probably the first example that we're seeing worked on other chains like Aave, Compound, etc. They sort of yeah invented that way to get yield, and now we're seeing a lot of the Bitcoin L2 adopt those protocols. So I basically think anything that is working on other L1s or L2s will eventually end up on Bitcoin, or on Bitcoin L2s.
Wow.
Now,
Tell us a bit about your yield. It sounded like you done a bit of research on that and whatever. What are you doing with that?
yeah, so I run BitcoinYield.com. It's a research newsletter where we really dig into yield products. So where does the yield come from? What are the security assumptions? What are security risks that you take for trying to chase this yield? Last year, obviously, like the treasury narrative was very hot, and we're seeing more and more companies have Bitcoin
Yeah,
on their balance sheet. And so we're seeing a flight to yield products, right? So a lot of the CFOs they were asking, how do I make this a productive asset? So Bitcoin Yield fills basically does a lot of the research, and we interview a lot of the founders that have yield products out for Bitcoin.
yeah. And you reckon it's looking good? It's a solid, but because I mean, what do they say? Bitcoin is the yield, so don't go out on a limb. So I mean, is it still,
Yeah, I think
risk return?
I probably wouldn't place my Bitcoin all in one place to get yield.
Yeah,
Um, but I think there are definitely some yield sources that are secure. Um, Maybe are temporary, but that are
yeah,
secure and that are it's worth getting some yield from. So I mean, I won't say which names, but some of the L2s that have a wrapped Bitcoin equivalent, so like RBTC or SBTC or WBTC, etc. Some of them
yeah,
just have like marketing money that they're burning by offering yield for holding their wrapped Bitcoin. Like
yeah,
that's a very low security risk, and you know where the yield is coming from. It's probably temporary, right? Because that VC cash is gonna dry up eventually. But
yeah.
yeah, the safest way to get yield though is definitely Lightning Network. The
Okay.
Lightning Network is the best way to get yield, but the yield there is complicated, because you need to have a lot of Lightning expertise. But for example, Block earns 9%, 10% yield on Bitcoin on Lightning itself. To give you an example,
Anybody else got a question? Just put your hand up. It is
which
Lightning Network
L2?
still a thing?
Yeah, of course it's growing.
Is it really
Alejandra,
growing well? Because there was so much publicity around it in the early days, but I haven't heard a lot about it recently.
Yeah, it's still there. It's still growing. It's just not as exciting as other things because it's just payments,
Yeah,
right? And so with stable coins taking a lot of that payments narrative,
yeah,
it's just not talked about nearly as much. But yeah, Bitcoin's Lightning is alive and growing and changing.
cool, cool.
Alejandro, which L2 built on top of Bitcoin do you think is will be more successful or has been getting more traction recently? What does it solve? Um, I'm a big fan of, and again, a lot of these are clients of mine, so I have to be careful here, but I'm a big fan of stocks. I'm a big fan of Liquid, and I'm a big fan of Arcade, all for different reasons. So stacks and stacks and Liquid, I'm a fan of because they both have much more expressive smart contract worlds where you can build a lot of DeFi protocol, a lot of what you see in DeFi protocols on other chains, and then use your wrapped Bitcoin with it. Um, so I'm a pretty big fan of both of those L2s. They're different in their architectures, which has different flavors, right? Like Stacks has its own token, which is definitely a plus or minus depending how you view it. It has its own smart programming language called Clarity, which also is complicated, but it has some really neat features to it. Then on the other side, Liquid, which is Blockstream's L2. It has a really interesting architecture to the blockchain itself, which it uses UTXOs. Not a lot of other L2s use UTXOs, uh, but Liquid does. And so that to me is a really beautiful feature because it maps to how Bitcoin works very, very organically. And then Arcade, I'm bullish on. Um, to give you guys a long story short, there is a new Lightning-like protocol called Arc that was designed about 2 or 3 years ago, and that there are now teams coming out with the first implementation of it. One of the teams is called Arcade. And I say it's Lightning-like because it's basically off-chain Bitcoin, where you're still dealing with native Bitcoin. It's not wrapped Bitcoin. It is just you're doing a lot of things off-chain. But it has pretty much the same security assumptions as Lightning Network. So I like that. Those are like three of the L2s that I'm a big fan of. And what problems does it solve? Again, introducing all the other DeFi protocols and primitives that we're seeing on other blockchains slowly gain adoption. So even stablecoins themselves, or again, lending or providing liquidity or escrowing or like any of these things that have found product market fit in other blockchains should and probably will end up on Bitcoin or infrastructure on top of Bitcoin.
That's fascinating. Wow. Cool. Well, anybody else got any questions? Because we're on the hour now, and I know it was a bit shorter than usual, but people probably got other things to go and do. Any last questions from anybody?
Going
Going once,
once.
going twice. Well, Jesus, thanks so much, man. Yeah, it actually sped up. Yeah, at the end there, I've got actually quite a lot of things I would ask you, but anyway, let's call it here. It was fantastic. Sorry to have left you out in the cold. And
No
thanks
worries.
everybody for being here. Yeah, we'll put it up on the YouTube channel so anybody that didn't make it can have a look at it. And we'll also put out some tweets and some LinkedIn posts just to celebrate having you with us and
Perfect.
your
Thank you
wisdom
so
insight.
much.
Thanks a
I
million.
appreciate it and appreciate the time. Thank you guys. Hope you learned.
Awesome.